Welcome to this comprehensive guide for beginners on C# reflection, a powerful and essential feature that allows you to inspect and manipulate types, methods, properties, and other metadata at runtime. This capability enables dynamic discovery and interaction with code. Reflection allows code to examine and modify itself during runtime. It enables discovery of information about assemblies, types, and members while the application runs. This dynamic capability is useful when code structure is unknown at compile time. Dynamic discovery is crucial for building highly adaptable and extensible applications. Your program can interact with code components not explicitly linked at compile time, providing significant flexibility. One compelling use case for reflection is dynamic plugin systems. It allows loading and interacting with external plugins at runtime without prior knowledge of their types or structures. This extends and customizes applications post-deployment. Serialization libraries heavily rely on reflection. They facilitate automatic conversion of objects to and from data formats like JSON or XML by dynamically inspecting an object's properties and fields. This enables seamless data persistence and exchange. Unit testing frameworks utilize reflection extensively. They enable dynamic discovery and execution of test methods within your codebase, allowing for automated testing processes. This ensures code quality and helps maintain robust software development practices. Reflection enables late binding, where the assembly to load is determined at runtime, offering greater deployment flexibility. It also assists code analysis tools in inspecting code structure for validation, documentation, and advanced development tasks, providing deep insights. Next, we delve into the system. Type class, the cornerstone of C# reflection. We'll explore how to obtain a type object and inspect fundamental information about any .NET type, understanding its core metadata. The system, type class is central to C# reflection, representing type declarations like classes and interfaces. It's your gateway to understanding a type's metadata, including its name, properties, methods, fields, and events. You can obtain a type object using the typeof operator for known types at compile time. For example, type T equals typeof directly retrieves the type object for the program class. The second method uses getType, inherited from system, object, to retrieve the type object for an existing instance at runtime. For an object obj, use type T equals obj.getType to dynamically discover its nature. With a type object, access properties like name for the simple name and full name for the fully qualified name, including its namespace. This provides a complete and unambiguous identifier. Retrieve the assembly where the type is defined for crucial context. Boolean properties like isClass, isInterface, and isValueType quickly determine the type's fundamental kind you are inspecting. The type object is your entry point to discovering a type's members. Methods like getMethods, getProperties, getFields, and getEvents return arrays of method info, property info, field info, and event info objects, representing all type members. Now, we inspect properties using the property info class for detailed metadata access. We'll learn to obtain property info objects, examine details, and dynamically read or write values from an object instance, enabling dynamic data manipulation. The property info class provides comprehensive access to property metadata. It represents an object state accessed via get and set accessors. With property info, you can discover details and dynamically read or write values from an object. To get property info objects, use type.getProperties for all public properties. If the name is known, type.getProperty returns a property info for that specific property, allowing targeted inspection. With a property info object, inspect its characteristics, name for its identifier, property type for its data type, and canRead/canWrite for getter/setter presence, defining its access capabilities. Retrieve accessor methods. Get method returns the method info for the property's getAccessor and getSet method for its setAccessor. This allows deeper dynamic manipulation of property values. The most practical use of property info is interacting with property values. GetValue retrieves a property's value, while setValue dynamically sets it on an object instance. For an example, we define a simple student class with public ID and name properties. These auto-implemented properties are ideal for reflection demonstration and dynamic inspection. In main, We obtain the type object for student using typeof. Then, type.getProperties retrieves all public property info objects associated with the student type for detailed inspection. We iterate through the properties array, printing each property info object's name and property type. This demonstrates dynamic inspection of basic property metadata and the student class's structural details. Next, we create a student instance and initialize properties. We use type.getProperty to get its property info, then nameProperty.getValue retrieves the actual string value of the student's name. Moving to methods, the methodInfo class provides comprehensive access to method metadata. We'll obtain methodInfo objects, inspect details like return types and parameters, and dynamically invoke methods at runtime for flexible execution. The methodInfo class provides detailed access to method metadata, including name, return type, and parameters. Crucially, it empowers dynamic method invocation, a cornerstone of many advanced C# patterns and frameworks. Similar to properties, get methodInfo objects using type.getMethods for all public methods. If the name is known, type.getMethod retrieves the specific method info for that method. With a methodInfo object, inspect its characteristics, name for its identifier, return type for its data type, and get parameters for an array of parameter info objects representing arguments. Determine method accessibility and characteristics using Boolean properties like is public, is private, is static, is abstract, and is virtual. These provide a complete picture of method behavior and access. The most powerful aspect of methodInfo is dynamic method invocation. Invoke calls the method on an object instance with specified parameters. This allows execution of methods whose names are unknown until runtime. For our method example, we define a simple calculator class with a public add method. It takes two integer parameters, a and b, returning their sum, and will be our target for dynamic invocation. In main, we obtain the type object for calculator using typeof. Then, type.getMethod retrieves the method info for the add method, preparing it for dynamic use and execution. We create a calculator instance and define parameters 5 and 3. Calling add method, invoke executes the method. The object result is cast to int and printed, demonstrating successful dynamic invocation. Reflection is powerful but has practical considerations. This section covers tips on performance, caching, security, and error handling to use reflection effectively and responsibly in C# applications. Reflection is slower than direct method calls due to runtime checks and metadata access. Avoid overusing it in performance-critical code sections where speed and efficiency are paramount. To mitigate performance, cache type, property info, and method info objects for repeated access, avoiding redundant lookups. For faster invocation, consider delegates created from method info. Be cautious with reflection, especially with untrusted code. It can bypass access modifiers, accessing private members. This powerful capability introduces security risks if not handled with care and proper input validation. Implement robust error handling. Check if a method, property, or field exists before invoking it to prevent runtime errors. Wrap reflection operations in try-catch blocks to gracefully handle exceptions. In summary, C# reflection is a versatile and powerful tool for dynamic code interaction. It's essential for flexible plugin systems, efficient serialization, and unit testing frameworks, unlocking new dimensions of programmatic control. Mastering system, type, property info, and method info allows you to inspect and manipulate code at runtime. This leads to highly adaptable C# applications and empowers more dynamic, extensible software solutions. Always balance reflection's power with careful consideration for performance and security. Strategic use, combined with best practices, ensures robust and efficient applications. Thank you for joining this deep dive into C# reflection. We hope this guide provided a solid foundation and practical insights to confidently apply reflection in your programming journey. Happy coding!